Hello and welcome to Talk to My Car. At Talk to My Car, we have ways of making your cars talk. Today, our chat is going to be about O2 sensor operation. Most modern cars, that is from around 1990 or 1981 onwards, especially petrol ones, with EFI engines, that is engines whose operations are controlled by computers, have oxygen sensors in the exhaust stream. The oxygen sensor is the reporter for the engine computer. The oxygen sensor informs the engine computer or the ECM about the content of oxygen in the exhaust stream. The computer wants to see a certain concentration or content of oxygen in the exhaust stream to maintain perfect mixing ratios for the fuel and the oxygen. Below and above that oxygen concentration, the computer tries to correct the situation. If there is a lot of oxygen in the exhaust stream, that means there is little fuel or there is too much air going through the engine. And if the oxygen content is below a certain figure that the computer is happy with, then to the computer that means there is either excessive fuel going into the engine or too little air. Maybe there is a restriction of air going into the engine, and so on and so forth. Basically, we have two scenarios: either too little oxygen or too much oxygen for the sensor to report. If the concentration is perfect, that's what the computer likes to see, and it will try to maintain that by controlling how much fuel is going into the engine cylinders. Now, most of you who have come across oxygen sensors on exhaust manifolds of EFI operated engines will have recognized that they usually have 4 wires. As you can see in this image, we have a black wire, which is usually the O2 signal. This might vary depending on the manufacturer, but I'm showing you the most common configuration. And then we have a gray wire, which is the oxygen sensor ground. And then we have 2 wires that usually have the same color, normally white. Those are usually for the oxygen heater. Perhaps I need to explain here, for oxygen heaters to work efficiently, they needed to be heated to about 600 degrees centigrade. And that's why most oxygen sensors will have a heater tied in. So you will normally have one of the oxygen heater wires going to the battery positive, so it will have 12 volts via a fuse, and then the other will of course be the ground. The battery positive 12 volts coming to the heater will usually go through a relay, which may or may not be actuated by the engine computer. So that's the commonest configuration for this type of oxygen sensor. It's the commonest and the older type of sensor. and it's called the narrow band. There is another type of sensor called the wide band, which I'll explain further on into the video. All you have to know is once the oxygen sensor heater is working properly, a properly operating oxygen sensor should cycle between 0.85 volts and 0.15 volts. Now, the more oxygen the sensor detects in the exhaust stream, the lower the voltage will go, and that's why here I'm showing you the lower voltage 0.15 is a lean kind of condition, and the lower the concentration of oxygen, the higher that voltage will be, and that's why you see here the voltage is on the higher end for that cycle. Also, you need to note here that if the oxygen sensor heater circuit is not working, if the heater of the oxygen sensor is not working, you will have higher voltages than this figure here, 0.85 or 1 volt, and that means the computer all the time will be seeing a rich condition, so it will be deceived that there is excess fuel in the mixture, and so what it will try to command the fuel injectors to dish out less fuel, and as a result most engines will misfire and even stall eventually. So here I'm showing you how the oxygen sensor voltages cycle. What happens is the oxygen sensor is not the one that cycles or reduces or pushes the voltages up or down. It's the computer that affects it by... Perhaps I need to explain what the computer is trying to do. The computer wants to maintain voltages along this straight line about 0.45 volts. So what it will do, it will inject extra fuel, a little bit extra fuel every about once a second, and then the mixture will try to go rich, and the sensor will detect that, and it will report to the computer. The computer will see it, and then the computer will try to reduce the concentration of fuel and increase that of oxygen by reducing the fuel it is dishing out, and then the voltage will go down, and then it will do the reverse over and over again. So it will cycle over and over again, in effect trying to maintain this voltage around an average of about 0.45. So that is why on a normally operating oxygen sensor, at least the narrowband type, you will see the sensor voltages cycle around like you see in the video on the screen. The narrowband operates in a different style, which I'll come to further on into the video. I hope you've got the essence of that. It is not the sensor itself that keeps changing the voltages. Yes, it is the source of the voltages, but it doesn't cycle them intentionally. It is the computer which is actually playing around with the fuel mixtures to keep that voltage at an average of 0.45, but in doing so, it keeps that cycling of fuel mixtures cycles the concentration of the oxygen as well, and that's what the computer, rather this oxygen sensor, reports back to the computer. Now, as I explained earlier, if you bring your car to talk to my car, and we put it on our equipment and pulled out a code related to the oxygen sensor, before you go out and buy another sensor and replace it, you need to check the circuits of the oxygen sensor, because sometimes it's the circuits that have a problem, or the computer itself that has a problem, and not the sensor. So before you change parts, anyhow, just because you've got a code, please check the circuits to make sure that both the computer and the wiring are okay. And the only problem then would be the sensor, which you are now comfortably going to buy confidently. Like I mentioned before, this black wire is the ECM signal pin. The computer will put 5 volts on that wire, and the oxygen sensor will pull that voltage down, the 5 volts down, to between 0.85 and 0.15. As I mentioned earlier, it will be cycling between that. If you see higher voltages than this on the sensor with it plugged in, when the sensor is plugged in, if you keep seeing higher voltages than about 1 volt, you can be sure that this heater is dead. And then the next step would be for you to pull the sensor out and look at these terminals, do a continuity test on them to check that everything is fine at that point. So briefly to recap on that, make sure with the sensor plugged in, you have the voltage cycling at below 1 volt. If it's higher than that, these heaters are dead. You can do a continuity test to prove using an ohmmeter, and then before if that test is negative, if the continuity test is negative, then what you have to do is check for the voltages. One side should be going to the ground circuit, like shown here, to the heater ground circuit, and this side is going to the heater relay, 12 volts. So you should be seeing 12 volts on this, very near 0 volts on this one. Make sure you do the test, the grounding, the ground circuit test. And then this one is the ground wire for the sensor itself. This is a 5 volt signal wire, which is brought down by the sensor, and then this should be very near 0 volts, same as this. Both of these ground wires. Now I mentioned earlier, the description of operation I've just been giving you is for the narrowband oxygen sensor. Now here I'm going to try to explain to you how the wideband oxygen sensor works. This works slightly differently. It still does the same job as the narrowband oxygen sensor, but it does it in a better way. It has 5 wires, as you can see from this pin here. Now this one doesn't lead to cycling, because this is briefly how it works. In here you have the sensor heater. This type of sensor will also require heater, so oxygen sensors usually have heater circuits. So you have one wire for the heater terminal here and another one for the heater terminal here. This is the heater element in here as indicated. And then you have these wires which might have different voltages depending on the manufacturer, but usually about 2.3, 2.4 volts. What happens with this type of sensor, it should see, the computer wants to see 0 current flowing in this section of the sensor. Now if there is a difference in voltage between this wire here and this one here, a current will flow through this medium here. What the computer wants is to see no current flowing here. If it sees current flowing in a certain format, in a given direction, say because this voltage is slightly higher than on this side, it will try to it will react in such a way that the exhaust fumes coming into this sensor monitoring chamber, the concentrations of those fumes change so that the voltages on these wires balance. If this is higher than this, it wants to see this go down and this go up until they balance out, and vice versa. So it also has a positive and negative kind of thing. But with this kind of sensor, if it's operating normally, it will not be cycling. The voltage, the current will be very near zero. The voltages on these terminals will be very, very similar to each other. And the fifth wire, which is not shown here, will be the ground for this sensor. These are voltage wires coming in, and these are actually signal wires for the computer, and this is what the computer looks at, compares this to this. The sensor should have a sensor ground, and that's not shown in this image, but just know it's there and explains the 5 wires you saw earlier. And this type of sensor, the wideband oxygen sensor, is sometimes referred to as the AirFuel Ratio sensor. That's why you see AFR being mentioned here, and it outputs an inverse signal. In other words, if the mixture is rich, as in it has a lot of fuel in it and less oxygen, the temperature, rather the voltage, will be lower, and vice versa. Now, I usually like to use wiring diagrams so that you have some guidance when you're doing these electrical tests on any vehicle you are tackling. It could be yours, or you could be a mechanic in a garage. Here, in this case, I've used a wiring diagram from a Nissan hard body, 1997 model, with a petrol engine. There are a lot of things shown in this diagram, but let's focus on the oxygen sensor, which I have highlighted here. And like I mentioned earlier, this has a narrow band oxygen sensor. So like I mentioned earlier, there are 4 wires. There is a red wire here. That's, you can see it came from the ignition switch and a fuse, so that must be carrying 12 volts. It comes like that through that. So that, then the only wire that should have 12 volts on it at the oxygen sensor is a heater positive voltage wire. So that is this wire, and then this black one is the negative wire for the oxygen heater. This one also is a negative wire, as you can see, comes like that, like that, like that, and like that, and you can see it goes to 3 grounding or negative terminals that eventually lead to the negative terminal of the battery. But even without an explanation that this is the sensor negative ground wire, you should be able to tell, because you see the thing like rings around these wires, the black and green wire. That's showing you that that's a shield. Normally, for sensors that are very critical to engine operation, they are shielded so that their signals are not corrupted by wherever the wire is passing, say near big magnets like in alternators. So whenever you see a shield, those wires must be sensor circuit wires. So there is no point in shielding this heater wire. So this can only be a sensor circuit, and because this is leading to the grounding side of the circuit, this is obviously for this sensor, this is obviously the sensor ground, and the green wire coming from here to terminal 52 in the back of the engine computer, that must be the signal wire. Like I mentioned earlier, the computer here, the ECM, tries to push out 5 volts, but they are reduced by this oxygen sensor in normal operation, as I explained earlier in the video. Once again, I thank you for your time. We are here to save you time, money, and headaches. We at Talk to My Car, in partnership with SSK Motor Garage, very happy to help you whenever you need any assistance regarding vehicle diagnosis, because that's what we specialize in. We diagnose and fix cars. So, but we try to share information like we're doing now. If there's any more information you require regarding this video or anything else or any other videos we've published in the past, please contact us at the number you see on the screen. And you can also join us at our Facebook forum, which was shown in this video at the bottom of the earlier slides. Thank you for your time. Please come again and get more videos from us and share ideas. Bye.